Well, the drive line being the pipe, the wheels every 40 feet down that pipe, we then have to be able to roll that thing across the field with that drive line. So we have to hook it onto that mover with a flange adapter. This happens to be a 5-inch. We're going to press a piece of 5-inch onto this, and then this is going to bolt right onto the mover. And then the mover is going to have a big gear on it that's going to drive this, and this is going to roll with the pipe attached onto it. And instead of one press band, because there's so much force right at the mover itself, we have 2 of these press bands that will go on the pipe as we press it on, so that we get more of a swedge fit and more pressure holding that pipe between the coupler and the pipe. So we're swedging that down really tight to make that work. And so we're going to have 2 press bands on that particular piece. Then this simply bolts right on to the mover bull gear. There's a large gear on the mover, about this big around. It's being driven by little motors on the sides, so it moves at a very slow rate. We want that gear to turn at about 1 revolution a minute. And so we got ourselves a little gas engine driving the mover. And that little gas engine is going to be generally around 8 horsepower. Different engine manufacturers make Briggs & Stratton, Kohler, and no doubt there's others out there, Tecumseh, that are going to make those kind of engines that are available to be put on a mover. A mover is a big tube here. That pipe's going to hook up and come right at us right here. So the wheel line pipe is going to be right here. And so that's where that flange adapter is going to hook up. On the outside of that pipe is the bull gear that it's attached to. And it's toothed all the way around the outside. And then it's driven, most of the units are driven by hydraulic orbit motor. And those little orbit motors are sitting here on the ends. They're anchored right in here. And they're toothed as well. And they're being driven by high pressure hydraulic fluid. So there's a little hydraulic pump. And that's being driven by a shaft from the gas engine. So we got quite a bit of mechanics out there operating. We got to start a gas engine, goes to an oil pump, which then is driving the pump. Then we have an adjustment handle. We can determine how much flow we want, because with oil, all you have to do is how fast you want these little oil motors to drive. They're called orbit motors, by the way. We can determine how fast they go by how much flow we put through them. More flow, the faster they go. Less flow, the slower they go. Plus, we can make them go reverse. Throw the handle of the reverse, make the flow go the opposite direction. They turn the opposite direction. So we have forward, reverse, infinite speeds, both directions. Now, we're going to, from this parcel of information, we got to have a some kind of a flow regulator. So there's a handle here that's going to be feeding into these orbit motors. We're going to have hydraulic tubes running from the lever that's regulating direction and flow to each of the motors. So when we put it in the neutral position, no flow. Put it toward forward, we're going to start getting forward flow up to maximum speed forward or back reverse. We can go from 0 to maximum speed reverse. Ideally, these need to run about 60 feet a minute. That tends to be about the right pace to walk a wheel line through a field. Depending on how much crop interference you have, you can imagine if you have a freshly cut hay field, it's going to roll very freely. If you have a full-grown stand of wheat and the wheat's even hitting the tops of the pipe some, there's a lot of resistance to rolling that thing across the field. So there's a lot of drag to it. And so the operator has to be smart enough to observe how that thing is rolling across the field. He can be going too fast or he can be going too slow according to the crop conditions. You get going real fast and the things will just take off if you have a real smooth field. They use wheel lines to irrigate some turf farms. Well, gosh, they'll roll real free across turf. There's no interference at all. And so you get going too fast and the ends start to get ahead of you. They'll get going, you know, you got that whip effect because that drive line, it takes a while to get that end wheel moving. It's out there 16 wheels. The first wheels move immediately as soon as you start moving the mover. But it takes a while for that axle to get that end wheel moving. But once it gets going, it's going to have a little added speed to it. And it's going to want to roll real rapidly at that point if you're going too fast. Now, if you're in a real heavy foliage, then it takes a lot of energy to get those wheels going out there. Sometimes you even have to have extra help by going out and pushing them forward. And I've seen fields where they've had to put 5 or 6 people out to help keep pushing the wheel line forward in wheat when the wheat gets up really tall. That dwarf wheat sometimes isn't as dwarf as you want to think. And it grows right up into the wheels, and then it's real hard to move that wheel line through that field. So sometimes you do have to give it a little assistance. Sometimes you have to move the mover past the point of where the line's going to stop so that the ends can get caught up and then reverse it to bring it into place. But that's just operations.